Okay, great. So I think there is no technical difficulty as such. So we are ready to start. Okay. So I'll just show you somebody. Okay. I just want you to identify who this great person is. All of us have learned about him in our textbooks. It is time for you to recognize who is this famous person. Okay. So on your screen, you can see this famous person. Identify who this person is. Okay. So I will change the screen. So if you know him, you send me via chat who this person is. Is my voice better or is it still echoing? If it is still echoing, then click on no. If it is better, click on S icon. Okay. So if you have some issues, just text me. Okay, so it will get better. Don't worry. So many of you guessed it correctly. Yes, he is none other than Galileo, and we're gonna see one of the theories put forward by Galileo, which the world mocked at him. Okay, the world said that you are mad. Okay, regarding the theory that he had proposed, and everybody objected. Okay, so let us go back and see the experiment which made Galileo true, that whatever he had anticipated regarding the theory, okay, so that was proved in this particular experiment. So let us see what was that experiment. This is one of the famous experiment, ball versus feather. Okay. Okay, so as you could see in the experiment, okay, so when you remove the air, okay, both the feather as well as the ball, even though there's a big difference in their mass, but still both of them would fall at the same rate. Okay, so you may feel that the ball is heavy, the ball should fall first and then the feather. Okay, but actually they both will fall at the same rate. Okay, so when Galileo had proposed this long ago, around 1550s or something, people did not believe him. Okay, but after Newton's theory and all this laws of gravitation, and after so long, then they started believing what Galileo said was actually true. Okay, so when we come to gravitation chapter and all, so we learn more about such things. Okay, so now let us just start from where we left yesterday, so which is the graphical representation. Okay, so if you remember, yesterday we did graphical representation only of distance versus time graph. Okay, so we will continue from there. I'll just have a quick revision so that I know that all of you have understood the topic. Just like yesterday, I want to conduct one small recall test to check whether all of you are understanding everything or not. Okay, so this is a small test on SI units. SI units test. Yesterday, I did formula test. If you remember in the beginning of the chapter, sorry, in the beginning of the class. Okay, so today I'll conduct this SI units test. I will give the quantities on one side and I'll write the units on the other side, and you should be able to match them correctly. Okay, it's match the following, just like yesterday, same format. Okay, so let us see how many of you can do this correctly. Okay, so I'll just quickly make a table. So I have this table. So you have to match the correct units. Okay, from the quantities which I have mentioned here. Okay, so I'm just starting with few of them. Okay, so I will give them the names also. 1 second. Okay, so I'll make two options. I'll raise a poll and you just have to choose which option you think as the correct option. Okay, so option A, so I'm gonna put it as option B. Okay, so if you think option A is the correct match of the quantities, see, P means all this P, Q, R, S are your quantities, and the units have mentioned in 1, 2, 3, 4. I hope what I have written here is visible and you can understand. For example, the first one, P matched with 4. That means acceleration matched with 4 meter per second. ISA. Okay. Similarly, I've done for other things. Option A is there. Option B is there. Only two options. Whichever you think as the correct, on your screen, you will see the poll. Okay. And you have to choose the correct option. Okay. So let me see how many of you can get this correct and you are familiar with the SI units. Okay, fast. So please vote. Okay, fine. So last 10 seconds. So please finish it. 5, 4, 3, 2, 1. So let's just stop. Time up. And I'll share the results. So you can just see on the screen. So 86% of you have selected option B, and some of you selected option A. And let's just check who is correct and who is wrong. Okay, so let's come back to this question and see what should be the answer. So the first thing, so acceleration has units of meter per second square. That means it should be matched with 2. Okay, P should be matched with 2. Over here, P is matched with 4. That means option A will straight away become wrong in the first case itself. Okay, so acceleration should be matched with meter per second square. So next you have velocity. So velocity SI unit is meter per second. Either you can go with 3 or 4 because both of them are the same. Okay, speed is also having same units, meter per second. Okay, and the last one, displacement. So displacement SI unit is meter. Displacement SI unit is meter. Okay, and hence of all the cases, option B is our correct answer. Okay, see, never get confused. Units are very, very important. Units are very, very important. How important are these units? In the next example, I will not tell anything, but you will only guess the correct answer. Okay, so just watch out what I'm trying to do here. Okay, so I'll again make one table, but this time it is general common sense. At least this question, I expect 100% of you to tell me the correct answer. I don't want to see even a 1% telling wrong answer. Okay, so let us make one table and figure it out, the answers. Okay, so I'll just have only like 2-3 columns. So over here, I'll mention. Okay, so here I'll write the list of items. You have to tell which one would match with what. Okay. So my mother sent me to shop to buy the following items. That is sugar, chocolate, and milk. So now you tell me, I've written the units on the right hand side. On the left hand side, which quantity or which item should I place? Okay, which item should I place? Okay, so I will just take randomly one of you. I'll unmute you and you will speak. Okay, so I'm just randomly taking who will speak, who will speak. Bharat, Okay, so Bharat, you can talk.
Good evening, sir.
Good evening, Bharat.
Yes.
Bharat,
Hello. Yes,
tell
sir.
the answer, Bharat.
Sir, milk will be liters, sir.
Milk will be liters. Why?
because it, because it is a liquid quantity.
Correct, Alva. Nobody will
Yes.
sell you milk in kgs. Okay, because
Yes.
you also know, I also know the convenient way of measurement of milk is in liters.
Liter.
Okay, see, I didn't even tell you anything. I just wrote liters and you yourself identified it to be milk. Okay, why? Just by looking at the units. So now tell next answer.
Next answer will be sugar, sir.
Next answer will be
Sugar.
sugar. Correct. Because usually general way, see, if I go to a shop, I will not take 1,000 quintals of, or like 1 quintal, yeah, 1 ton of sugar. Or when I go to shop, I'll not buy 1 gallon of milk or something. Okay, so I would just use easily. I told simple example. Don't complicate yourself. Okay, I went to a simple shop in my home and near my home, and in the shop, as soon as I tell, they will give you in these quantities. Okay.
Okay, sir.
Next, chocolate.
Yes.
Next answer will be like remaining. That is the thing remaining. Okay. So chocolate, I just took 2 chocolates. Okay, because change was remaining, so I took 2 chocolates. Simple. Okay. So of course, my mother did not ask me to buy chocolate. She just asked me to buy sugar and milk so that she can make tea. But chocolate, that is my service tax. Okay, because I went to shop, no man, to buy stuff. Okay, so chocolate I took. Okay, so now, uh, hence, like just by looking at the units, you can figure out the quantities. Okay, so that is why you should be always perfect with the units. You should know which unit is for what. Okay, acceleration meter per second square, velocity meter per second, speed meter per second, displacement meter, distance meter. We have learned only this much. Okay, and you should never get confused. Okay, great. Thank you, Bharat. Okay, so now let's just continue with okay, so yesterday, yes, sorry, so I got muted. Okay, so yesterday we learned that distance time graph shows distance on y-axis. Okay, so it shows distance on y-axis, and x-axis you have time. Okay, so if I have graph like this, okay, so x-axis will be my time and y-axis will be my distance. Okay, because time is an independent quantity and time should be on the x-axis. Okay, so this is what we learned. Okay, and for uniform motion, our graph will look like this, a straight line graph with a slope like this. Okay, so I'll just draw it. So this is the nature of the graph. In the exam, they'll ask you the nature. How does the graph look like for a uniform motion? For uniform motion, the graph looks like this. Okay, so distance versus time graph, it will look like this for uniform motion. Okay, what happens for non-uniform motion? That is what we will learn in today's class. Okay, for uniform motion, yesterday we made a table, we plotted and all that. So similarly, same practice will continue, but today distance time graph for non-uniform motion. So I will write here distance time graph for non-uniform motion. Okay, so once we finish distance time graph, we will go to displacement versus time graph. Okay, so I'll write here non-uniform motion. Okay, so I'll give the data. Using this, you have to plot. Okay, you have to plot the graph quickly, and then we will discuss about the nature of the graph. So this is my table. So I'm writing the quantities, time, writing quantities, time, and here distance. Of course, time measured in seconds, distance measured in meters. Okay, so when time was zero, initially, before the motion started, time was zero, distance was zero. Okay, the motion did not start. So now, after the motion started, after the journey began, when time was 1 second, the distance covered was 3 meters. The distance covered was 3 meters. When time became 2 seconds, the distance covered was 10 meters. The distance covered was 10 meters. When time became 3 seconds, the distance covered was 15 meters. When time became 4 seconds, the distance covered was 25. Okay, so distance covered was 25. So now this is the table. Using this, please plot the graph and show me how does your graph look like. Okay, fast, quick. Okay, so I will also do in the screen, but meanwhile you also do on your own. Okay, fast. If you have some queries, you can send via chat. I will clarify. Okay, as soon as you finish it, you click on the S icon so that I know that you have completed the task. Okay, quick. And for those who did not who is not having any clue how to do, you watch the screen. I'm going to do it on the screen. Okay. Okay, so most of you have finished. So those who did not finish, not issue. So watch the screen. So I'm going to do it over here. Okay, and let me see if all of us got the same type of graph. So do not worry, in Max, there's a chapter, coordinate geometry. So there you will learn more about how to draw the graph, plotting and all that. Okay, plotting the points on the graph, x-axis, y-axis, everything in detail. You will again see in 9th standard Max, maybe 3rd chapter, coordinate geometry. Okay, so now, as I told you, time will be on the x-axis. Okay, yesterday we had discussed why time on x-axis, because time is independent quantity. Okay, and distance will be on y-axis because distance is dependent quantity. Okay, so and you have to mention scale also, please don't forget. So here I'm just starting with my the time. So this is 0 1 2 3 4 5 6 7. Okay, I don't need so much. So over here 5 10 15 20. Just make sure you plan properly and write. 10 15 20 25 30. Okay, so over here in my scale, x-axis 1 centimeter is equal to 1 unit. Okay, so whereas y-axis 1 centimeter is equal to 5 units. Okay, so this is my scale. Okay, so now let us just start plotting. Okay, 0 comma 0 will be my first point. Next 1 comma 3, when time was 1 second, like approximately I'm marking over here, my distance traveled was 3. And then when time was 2 seconds, the distance traveled was 10 over here. And when time was 3 seconds, the distance traveled is 15 over here. When time is 4 seconds, the distance traveled is 25. Okay, now when I try to plot the graph, okay, by joining all the points. Okay, remember I'm joining all the points. I joined all the points and my graph looks like this. Okay, and I'm gonna mark the points in green color. Mark the points in green color. Okay, so now as you can see, so the graph is a curve which is steeply increasing. Okay, look at the graph that we had got in the uniform motion. This is our uniform motion. The graph should look like this, a straight line having a uniform slope like this. Okay, this is how your uniform motion will look like. Non-uniform motion can be any shape, doesn't matter. According to this data, our graph is looking like this. Non-uniform motion can be of any shape, I saw something, whatever, except the straight line graph like this. It can take any shape. Okay, it can take any shape, because in non-uniform motion it all depends on how the object is covering those unequal distances in equal intervals of time. You remember the definition of non-uniform motion. So what did you learn in non-uniform motion? So non-uniform motion, uh, when Ashwin sir was teaching, so the definition, I hope all of you remember. If you do not remember, then I'm writing: when the object covers unequal distances in equal intervals of time. Okay, so the important keyword, unequal distances. Okay, so in non-uniform motion, unequal distances are covered. Okay, so hence your graph might look any shape. I'm writing it here, any shape. Okay, it can be any shape, where x-axis you have time and y-axis you have distance. Okay, so over here you need to understand that the graph can be of any shape when it is non-uniform motion. Okay, but in uniform motion the graph should be of this shape only. Okay, so that is what you need to understand. So can you please quickly note it down? If your graph part is done, then you can just write this. Okay, any shape. Okay, it can be of any random shape. Okay, so you please write this fast. Okay, just write the statement. Okay, and just draw one random shape, and you just write the definition also what I have written. Okay, object covers unequal distances in equal intervals of time. Okay, so my handwriting is little bad. I'll write neatly. Sorry. Okay, fine. So if you have done, then we'll see another interesting case. Okay, another interesting case where you have to plot the graph, and I will give the table. Okay, so quickly, there are only like three things. Okay, so we have done two things. Uniform motion we have done, non-uniform motion we have done. Let us see the third case. Okay, and this is important. Okay, you should understand why. Try to question yourself why the graph looks like that. Okay, how can you interpret the data? Okay, so I'm going to make the table, and you will tell me the reason why it looks so. Okay, so again I am writing time and distance. Huh. Please plot. Array, sorry, I made a mistake. Huh. Please plot. How do you think the graph should look like? And what can you understand from the graph? That is what I want. Your interpretation or understanding from the graph. Okay, so please plot this. Let us see what happens. Okay, always remember that from the graph, you can expect questions like the nature of the graphs. Okay, they'll give you the graph and they'll ask you what type of motion is it. Okay, that is the question that they expect. Okay, so please draw fast. As soon as you finish, you click on the S icon. Okay, fine. So some of you have completed. So others who are still doing, you can just see here. I'll also plot the graph quickly. So once I finish this, before I go to displacement versus time graph, let us have a small concept test to check whether you really understood all these graphs that we learned. Okay. So now when I start plotting, as I said, time on the x-axis because it is independent quantity. So once you start plotting, okay, you will realize that the line you will get is something interesting. Okay, so when time is 0, distance is 0. So white color, what you can see, I'm marking the points in white color. Okay, please notice carefully. So when time is 1 second, the distance is again 0. Okay. So when time is 2 seconds, the distance is still 0. Time is 3 seconds, distance is still 0. So I have to join all the points because that is how I get the graph. Okay. So once I join all the graph, you see it will be like this. Okay. So your graph is just coinciding with the x-axis. Okay. But what can you understand from this? Okay. So we understand from this that object is at rest. Okay. Object is not moving. Okay. Because you see, time will change. Okay. Time is changing, but distance is not changing. Okay. The object is at rest. The object is at rest. Okay. And the graph, like what you got, is parallel to the x-axis. Okay. Object is at rest. Okay. And the graph or the line, I'll write here, parallel to x-axis. Okay, so please note this. Okay, so please note this. When the object is at rest, so whatever line you get or whatever graph that you get, it will be parallel to x-axis. Okay, it will be parallel to x-axis. Okay, so this is another case. Okay, this is another case. So we have successfully completed all the 3 cases. I'll just quickly summarize in the form of nature of graph what you might get in the exam, and then we'll have one concept test. Okay, we'll see how many of you will tell me the correct answers. Okay, fast. Okay, so quickly you finish this. Okay, so I will just read what I wrote. This type of graph indicates that the object is at rest. Okay, and the graph is parallel to x-axis. Okay, the graph is parallel to x-axis. Okay, so now the next important thing is summary. Okay, so I will just summarize all this. Okay, and I'll write the graphs and I'll compare in front of you only. Okay, so I'm showing the just representation of the graphs. So I am doing like this. Okay. See, in the second case, wait, I think the graph is not straight. I'll do straight. Okay, all of these are distance time graph. Okay, all of these are distance time graph. Okay, the first one indicates uniform motion. The second one indicates non-uniform motion. Okay, the third one indicates object at rest because it is not changing. Okay, it is not changing. So I will denote this T for time and D for distance. Okay, like this. See, in the third case, initially it had already moved some distance, don't worry. Okay, but after that it is not changing. Okay, after once the time is changing, it is been constant. Okay, so that is why it is parallel to x-axis. Parallel to x-axis. See, I wrote here, if the graph is parallel to x-axis, that means the object is at rest. It is not moving in the journey. Okay, it is not moving. Even the time is changing, but it is not moving. Okay, so hence we just have the three things. It can even lie on the x-axis also. Okay, which graph? The third one, the last one, when the object is at rest. Okay, so hence these are the three types or the three natures of distance time graph that you should know. Okay, uniform motion, non-uniform motion, and object is at rest. Okay, so I believe this is clear. Okay, if you have understood this much, you please click on S icon so that I can conduct the concept test. So if you have understood, like all these three types, uniform, non-uniform, at rest. If you have understood all three, just click on S icon so that we are ready for this one. One small test, nothing big, man. It's easy. Okay. Again, match the following. I love match the following. Okay, cool. So please write it down fast, complete this. I will change the slide and let's have like another match the following question. Okay. So now let us see the match the following.
Vedesh sir,
Yes.
Aman here.
Yes, Aman.
Just quick thing. मैं next 5 minutes के लिए, if you are not launching a poll, can I launch? I want to conduct a
Sure.
teacher FPS.
Yeah, sure.
All right, okay. You can continue the class.
Ah,
Students,
okay.
you all can answer the poll. Na? Just please answer the polls, whatever the questions are. Please read the questions carefully and answer the questions. Okay.